Hello fellow problem solvers. Today we're going to be doing a problem in polynomials. This lovely problem is an introductory problem for you to work on polynomials and get more comfortable with them. As you try this problem out for a minimum of 10 minutes, ideally 30, not more than an hour. If you'd like to go along with us, give it a go for the next 5-10 minutes. Put your first ideas out on paper. And this is a sort of couple of idea problem. I don't want to spoil it. So what do we have? We have p of x, a monic polynomial. That means that of degree 4. So what does that mean? It means p of x is equal to x to the 4th plus something else. But the coefficient here, x to the 4th, is 1. That's what that means. And we have p of 1 is 10, p of 2 is 20, p of 3 is 30. Find this sum, p of minus 8 plus p of 12. How are we going to do this? Well, here's the thing. If you have n fixed points in a polynomial of degree n, not n fixed points, if you have n values given, that uniquely defines your polynomial. And we're going to prove that next time. So with that, we have 3 points given of a degree 4. It doesn't uniquely define it, but it kind of does constrain it. And we want to see, does this constrain the value of this in some way, shape, or form? So what is this? 1, 10, 2, 20, 3, 30. How do we get these numbers? Well, that is p of x minus 10x equals 0 for 1, 2, and 3. That's what this condition rewrites as. Now you can look at this as a polynomial q, and then you have q of 1, 2, and 3 are 0. So q can be rewritten as x minus x1, or in this case, x minus 1, x minus 2, x minus 3, times another x minus c for some constant c. And now we know this and this, in fact, have to be equal for some c, because these are zeros. So now we know that p of x is of the form 10x plus x minus 1 times x minus 2 times x minus 3 times x minus some c. And now here I invite you to pause and try to first understand like how it is we have this. But I invite you to pause for the next 20 minutes, 10, maybe 10 minutes, and try to figure out how you would push the problem further. And here's the next step. We try to calculate, let's see what happens when we plug these numbers in. When we plug in p of 12, what do we have? We have 10 times 12, okay, plus this is going to be 11 times 10 times 9. What is that? That's going to be 99 times 10, x minus c, or here 12 minus c. Okay, what is p of negative 8? Well, it's going to be, now it's going to be 10 times negative 8. And then we're going to have a plus negative 9, negative 10, negative 11. That's what we had here. And then positive c. So it's going to be, so it's actually I should put like 99 times 10 times c minus 8. Actually c plus 8, not c minus 8. Because when I get the minus out of every single one of these, it just flips. So now we have this. Because this, you could also look at it as 1 minus x, 2 minus x, 3 minus x, and c minus x. Right? So you have this is the case. And now when we add them, when we add these two, the c's will cancel out, and we will be left with 10 times 12 times minus 8. That is going to be 4, so it's going to be 10 times 4 plus 99 times 10. Let's put that out of parentheses, and then I have 12 plus 8, which is 20. Now I need to actually figure out what this thing is when we multiply it through. And the way I'm going to do that is get the 10 out. And what happens when I have the 10 out? I have 10 times 4 plus 20 times 99. Yeah, that is all good. And this is going to be 10 times, so this is 198. Right, that's 2 times 99. Add a 0 here, plus 4. It's going to be 1984 times 10. And that gives you 19,840. Incidentally, 1984 is when the Winter Olympics were held in my city. This finishes up our problem. And as always, thanks for problem solving.